All right, this is Open Up Resources 7.1.9 Scale Drawings. This is part 2. To get started today, I want to see if you remember anything from the last time we talked. Here is your My Favorite No warm-up. Pause the recording and get this done, and then we'll go over it together when we return. Okay, only continue past this in the recording if you have already completed the warm-up so that you can self-check it as we do the My Favorite No portion. Here is My Favorite No. Most of them were yeses, but here is My Favorite No. This is a really good mistake to make. I want you to talk about the things that they did well first. So please talk amongst yourselves. What are some things that they did well? Ready, set, go. Okay, and now share with me, what are some things that they did well? What are some things that you like to see? Carter? Yeah, there's a picture there explaining, a picture showing the work and an explanation. What else, Joshua? Circled the answer and included the units of measure. They had a label there. That's great. Okay, now, one more time, talk amongst yourselves. What is the mistake? What could we say to the student to help them understand better? Okay, and now come back and share with me. What is the mistake and what would you say to the student to help them do better? Trace. Yeah, I think that's really what the ultimate downfall is. They knew that this 40 was important. But what this 40 tells us, when we do that 280, because the original, or the bigger park, I should say, the bigger park is 280 yards. And so they knew that the 7 is related to this 280. So how are they related? They did the division. And from the division, they found this number 40. That number 40 is an important number, but it's not the answer. So what do we do with that 40 now that we have found it? Gideon. Exactly. It's like the scale factor, only we've got some different units of measure going on, but it's like that scale factor. So how did this 7 change to a 280? Because we multiplied by 40. So we're going to reuse that 40, but this time we're going to use it in order to figure out what the actual park width is going to be. So 5 multiplied by 40, and 5 multiplied by 40 is 200. What do we do with that 200 at that point? That 200 is just the answer? Thank you. We have to make sure that we pay attention to the units of measure. We're going from inches to yards, so our drawing is going from inches to yards. The width is going to be 200 yards. Okay, really good. Most of them were yeses, but I really like this mistake. I've seen this mistake happen a lot. This ends up being a two-step problem where we first need to figure out how we're getting from one figure to the next, how those numbers are changing or how they're related. Then once we find that number, we're not quite done. We need to use that number one last time. So I've seen that mistake a lot, and I'm really glad that we got to discuss it. So hopefully you guys don't make that same mistake on your test. Let's now continue on with Unit 1 lesson, it's actually lesson 9. We started with just a little preview from lesson 7, but really truly it's lesson 9, creating scale drawings. At this point, everybody should have a ruler, so even students watching the video, you need to make sure that you pause the video so that you can go and get a ruler. You're going to need that today. Last call for students in class, you all have your rulers. All right, and Unit 1, Lesson 9, Scale Drawings. Let's review what we saw here. Can you describe what is a scale drawing? Let's quickly review. What's a scale drawing? Thank you, Grant. Great, yeah, so it's a lot like scaled copies. That's why we're talking about it in the same unit. It's like scaled copies, but with scale drawings, we're going to have some sort of unit of measure that kind of relates the drawing to the actual object. I think that's a great summary. And so we were getting to the point where we were creating our own scale drawings. We weren't quite there yet, and that's what we're going to be doing today. But what we saw last time is, this was the rough sketch. not a scale drawing, but this was a rough sketch. And we were wanting to know if using this rough sketch, if these were the actual measurements of Noah's bedroom, then what would the scale drawing lengths have to be? And we could see that we actually can represent this with equivalent ratios. And recognizing that is going to be really helpful for what we are going to be doing today, which is, oops, I gave you too much. We're going to be creating our own scale drawings. We're going to be doing scale drawings of the shape of Utah. Now, you guys have the advantage of living in Utah. How would you describe the shape of Utah? Talk amongst yourselves first. How would you describe the shape of Utah? And now, in case anybody needs some help, there is a visual now. Okay, and now come back to me and tell me. How would you describe the shape of Utah, Devin? Yeah, it's like a rectangle with what could be maybe a square. I think it's safe to say it's for sure another rectangle cut out of the corner, right? And so with that in mind, I'm going to draw that rectangle around the outside. Draw the rectangle that would look like Utah. And you'll see why here in just a second. So here is, ooh, I'm going to do this. All right, there's that rectangle. And you can see again that other rectangle that's cut out of the corner. So here's the measurements. A rectangle going all the way around Utah, that's that original rectangle that you guys described, is 270 miles wide and about 350 miles tall. I'm going to label that here on the screen. So 270 miles wide, and I already forgot what was the other measurement. 350. 350 miles tall. Let's keep reading. The upper right corner that is missing is about 110 miles wide and about 70 miles tall. So I'm also going to label that, but I'm going to need your help. 110 miles wide, is that right? Okay, so 110 miles wide and 70. All right, I did have a good memory on that one. 70 miles tall. All right, so those are our actual measurements. What we need to do now, what's the matter? I wrote 350. It's just really close to the 3, so it looks like a 6, but it is a 350. Is that better? Now you can see that it's 350. Okay, what you're going to do is you are going to be creating 2 different scale drawings of Utah. The first one, and that's all we need to worry about right now, we're just going to do this one at a time. Make a scale drawing of Utah where 1 centimeter represents 50 miles. Okay? 1 centimeter is going to represent 50 miles. Since we're going to be doing 2, here's what I suggest. Break up your page in half this way so that you have space to do the 2 scale drawings. And I made sure to print that page on a full-size sheet, right? So you should have enough space. On this side, this is where we're going to do the 1 centimeter is 50 miles. The other side, we're going to do the other one, but I don't even want to think about that one right now. I just want to draw the scale copy, a scale drawing of Utah where 1 centimeter is 50 miles. Now, I'm going to let you guys get a little bit of a head start before we officially begin. I want you to start thinking about how can we use this? How can we use the actual measurements to help us know exactly how long we need to be drawing each part over here? So I'm going to leave it on this screen while you guys discuss. I'm going to leave it on this screen while online learners pause the recording so that they can go through that same thought process. And then we'll come back together and figure out what those measurements would be and then draw it together. Pausing the recording now. All right, in case you were struggling trying to figure out how long each of these pieces needs to be, we're going to go over that part right now, and then we can draw our scale drawings. So we have a rectangle that's 270 miles wide. We also have that same rectangle that's going to be 350 miles tall. Now we can't draw it that tall, but we need to use a scale that 1 centimeter is equal to 50 miles. So please walk me through this. How are we going to figure out exactly how many centimeters my drawing needs to be? Let's do the 350. That one's a little bit easier. 350 miles. How many centimeters does that need to be? And make sure you're able to explain why. I need more hands on that. That's better. Thank you. Liv, tell me what you did. Okay, why did you divide by 5? Why did you change it to a 35? Talk me all the way through all of that. Because the number is 350. So why'd you change it to 35? Okay, that's great. So if we're doing mental math, there's some definite mental math strategies that we could use, like recognizing that 0 on the end is not necessary. But since we have our calculators as our tools, instead of trying to worry about how we would do this mentally, what would I type into the calculator? Gideon? Again, that's great, 350 divided by 50, but why? Where is this random divide by 50 actually coming from? Talk me through that part. Go back to Gideon again. Yep. Okay, so we recognize that the scale is 1 centimeter multiplied by 50, and then that's going to be 50, the unit changes to miles. So if I'm going to be going in reverse, instead of multiplying by 50, I'm going to do the inverse, which is to divide by 50. So in my calculator, 350 divided by 50, which Liv tells us, remind me, Liv, I can't remember what you said. 7 centimeters, great. So I know it's going to be 7 centimeters tall. And now, that same strategy for 270, right? So again, the scale is me multiply by 50 to go forwards, but I don't need to go forwards, I need to go backwards. So instead of multiplying by 50, I'm going to use the inverse and I'm going to divide by 50. That one I definitely cannot do in my head. So help me out, 270 miles divided by 50, what do you get? I need those hands. I told you I can't do that in my head. I need those hands. Thank you, Oren. 5.4. 5.4 what's our unit now? Centimeters. Yes, we're going from miles to centimeters. So at this point, I now know how tall and how wide I need to draw that outer rectangle. So let's make sure that students pause the recording and they're actually drawing that. You're going to get out an actual piece of paper. Well, it's going to be on this paper, an actual ruler, and you are going to draw that right length. 7 centimeters tall, 5.4 centimeters wide. Once that's done, then we can continue the recording to figure out how much we need to cut out from that upper right-hand corner. I'm going to pause the recording now so that students can get that drawn. Ready, set, go. All right, this is what you should have done on your paper. We're going to be drawing a height of 7 centimeters and a width, trying to make a right angle here. But without a protractor, it's not going to be super perfect. But now this is going to be a width of 5.4 centimeters. And repeating that same process, trying to form a right angle, 7 centimeters tall. Let's see how good I was. Is it 5.4? Pretty good, pretty close. Okay, there's my outer rectangle of Utah. We need to figure out how much I need to cut out. I need to do that precisely as well. So let's go back to the document. Let's figure out exactly how tall it's going to be. So this part here represents that outer rectangle. Now we need to repeat this process for that inner rectangle that's cut out. So that inner rectangle that's cut out, I remember, is 110 miles wide and 70 miles tall. So again, I need some help from students in class. What am I supposed to do here to figure out how big those measurements are going to be on my scale drawing? What do I need to do? I need more hands. That's better. Tanner? Yeah, we need to divide them by 50, just exactly what we did here. So it doesn't matter that this was the bigger rectangle, doesn't matter that this is the smaller rectangle, the scale works the same way. Going forwards, I multiply by 50, so going backwards, I'm going to divide by 50. And again, you guys have already done this, so let's see the hands to share those answers. 110 miles divided by 50. What do you get, please, Alexis? 2.2. And what's the unit going to be? Centimeters now. Great. And 70 miles divided by 50 is, thank you, Devin, 1.4, and the units are centimeters. That's great. So remember, this is that inner rectangle that's cut out. And returning to the dot cam, 1.4 and 2.2. You guys might need to remind me of those measurements again. We're going to do orange this time. Okay. 2.2 is how wide it is. Is that correct? Okay, thank you. There's 2.2 right there. And I forgot 1.4? Okay. 1.4. So that's the amount that's going to be cut out. All right, and there is my Utah. How did you guys do? Good? Then you're ready for the next part. Let me minimize this, go back to this now. So we have done one, and I'm gonna paste that onto here for our class notes later. But now, make a scale drawing of Utah where 1 centimeter represents 75 miles this time. So I know a lot of students in class, you guys have been working ahead. That's okay. You've been waiting for me to get caught up to you. But in this new one, 1 centimeter is 75 miles. So I'm not going to pause the recording. I want you guys to just guide me through this right now. If 1 centimeter is now 75 miles, I still have a total length of 270 miles and a total, excuse me, that was the width, and a total height of 350 miles. So how am I going to find how big those pieces should be in my scale drawing? What am I going to do this time? Raise your hand if you already know because you've been working ahead. Raise your hand if you need a little bit more time because you haven't been working ahead. Okay, that's fine. That's fine. That's more than I thought. So we are going to pause recording, let students figure this out, and then we'll come back in a second. Ready, set, pause. So if 1 centimeter is 75 miles, and I now need to represent 270 miles, how many centimeters is that going to take? Tell me how you're getting the numbers. Let's see those hands, folks. If you're still drawing, you need to stop drawing so that you can raise your hand and be engaged and help me out with these calculations. Cambria. Yes. And how did you get that? Exactly. And where did that random 75 come from? Is it really so random? Where did that come from? It's from our scale, right? How is this 1 changing to a 75? It's because it's multiplying by 75. But I'm not going forwards for this. I'm going backwards. So is multiplying by 75 going to get me there? That's why we need the inverse. We're going backwards. So we divide by 75. And when we divide by 75, just as Cambria says, you said 3.6, is that right? Yeah, 3.6. So this is going to be 3.6, and our units change to centimeters, because our scale goes from centimeters to miles or miles to centimeters, which means I'm probably going to follow that exact same process. That 350 is going to be divided by 75. And what do I get, Trace? Yes, 4.6. That 6 is repeating, so 4.6 over bar. Nice. That's going to be our outer rectangle. And because I don't have a good memory, I'm going to do just that, and then I'll worry about how much I need to cut out. So 3.6 and 4.6 over bar. So in my new one, I need to go back and I need to label this one. This was 1 centimeter to 50 miles. And this one here is going to be 1 centimeter to 75 miles. So this time, I did a, guys, I already forgot. Is it 4.6 repeating tall? Is that right? Class, I'm needing your help. Thank you. 4.6 repeating, 4.6 over bar. So how am I going to draw that? I'm going to go 1, 2, 3, 4. There's 5, there's 6, and I need to go a little bit more because it was repeating. This time I think I'll even label that was 4.6 over bar centimeters. Okay, and how wide do I need it to be? That was the 3.6, I believe. So the 3.6, trying to get my right angles again. There's 0.5 and 0.6. Going to continue forming that rectangle 4.6 over bar. And 3.6, almost a perfect rectangle. Okay. Now with that part done, now I'm ready to figure out how much I need to cut out. So returning to that, and again, I need your help, folks. So the part that's cut out is 110 miles and 70 miles. Is my strategy going to change from what I did up above here? No. 1 changes to a 75 by multiplying by 75. So to go in reverse order, I'm going to divide by 75. So 70 divided by 75, 110 divided by 75. And again, I'm going to need your help with these calculations. 110 divided by 75. Let's see the hands for that one, please. Thank you, Joshua. Yep. 1.46. Where's the over bar? Just over the 6. Thank you. What's the unit going to be? Centimeters. Thank you. And 70 divided by 75, Tanner? Okay, so just the 3 is repeating, so just the 3 gets that over bar, and that's going to be centimeters. Let's draw that. Remember, this is that inner rectangle that's been cut out. So I'm definitely going to need some help remembering these, so you're going to have to tell me one more time as I switch to this other screen. This is going to be cut out, was it 1.46 wide that's cut out? Okay, oops, wrong. Don't do inches, do centimeters. 1.46, so that's less than the 0.5. I'm going to mark it there. Probably a little bit inside. And 0.93 tall. So there's 0.93 repeating just a little bit after that. All right. And there's my second scale drawing of Utah. I'm going to take a screen grab of that. How do these two drawings compare? What does the choice, or how does that choice of scale influence the drawing? When I see this one, 1 centimeter is 50 miles, ended up being bigger than 1 centimeter is 75 miles. Why is that happening? Grant, get us started in that, please. Yeah, that's a great explanation. 1 centimeter is equal to a smaller amount. So that means I need more centimeters to equal that 350 miles. Here, 1 centimeter is equal to a bigger amount. So if I'm still trying to get to that 375 miles, I need fewer centimeters to access that big of a number. Joshua. Yeah, I love it in cookie terms, exactly. That helps me understand those other ones from our mental math the other day. The cookie terms really help us understand that. Will you repeat that one more time, slower, so that I can repeat it on the recording and they can make sure that they hear? Joshua, you repeat it one more time. The centimeters, okay, same amount of cookies. People. Good. Okay, so same amount of cookies, fewer people that want the cookies, more people that want the cookies. So if it's the same amount of cookies, we're going to share them among this few amount of people, everybody gets more cookie. If we have more people that want the cookies, we have to share that cookie with everyone that wants them. Now fewer people get those cookies. Love the cookie terms. So how do the two drawings compare? The 1 centimeter to 75 miles was smaller. And the cookie terms help us understand why. And now, that's the end of the lesson. It's time to summarize. If we want to create a scale drawing of a room, and the floor plan has a scale of 1 inch to 4 feet, we divide the actual lengths in the room in feet by 4 to find the corresponding lengths, but we change that unit to inches for our drawing. So, what does that really mean? That scale is 4 feet to 1 inch. So we say, oh, we can easily change this 1 into a 4 by multiplying by 4. So to go in the reverse, I would just need to do the inverse. We divide by 4. So if I have a 15-foot wall, as we continue to read on, suppose the longest wall is 15 feet long, we should need to divide each side, or divide that by 4, so that we can see the result is 3.75, and our units change from feet to inches as we move to that scale drawing. There's more than one way to express this scale, and this is what our next activity is going to lead to. These 3 scales are all equivalent, since they represent the same relationship between lengths on a drawing and actual lengths, 1 inch to 4 feet, but I can divide each of those by 2, and now I have half of an inch to 2 feet. Half an inch is half of 1, 2 feet is half of 4 feet. We could go even further, 1/4 inch to 1 foot, where I take this initial one and divide each part by 4. Any of these scales can be used to find actual lengths and scaled lengths, whether we're looking at going from the actual length down to the drawing length, or going from the drawing length to figure out how big the actual length is. This is one of the things that we ended up with. The size of a scale drawing is influenced by the choice of scale. For example, here's another scale drawing of the same room using 1 inch to 8 feet. So again, compare. This one was so much bigger. This one, so much smaller. And it's because now 1 inch represents a whole 8 feet, where up above 1 inch only represented 4 feet. So that did affect the size of the drawing. Notice this drawing is smaller than the previous one. Since 1 inch on this drawing represents twice as much actual distance, each side length only needs to be half as long as it was in the first scale drawing. Here is your cool down. A rectangular swimming pool measures 50 meters in length and 25 meters in width. So it's rectangular, 50 meters in length, and 25 meters in width. You need to make a scale drawing of the swimming pool where 1 centimeter represents 5 meters. Part of that needs to be, what's the length and width? I'm going to pause the recording as you work on this, and as students in class have a chance to work on it and think it through. Pausing the recording now. Focus on first the measurement so that you can then actually complete that drawing. Ready, set, go. Only continue on in this recording if you are ready to see the answer. 1 centimeter represents 5 meters. So I need to know 50 meters and I need to know 25 meters. How long are those each going to have to be? And what I should have seen is this scale is a 1 to 5. So I can multiply by 5. But since I need to go in this reverse order, that means I can do the inverse and I can divide by 5. So 50 divided by 5 is going to be 10 centimeters. And 25 divided by 5 is going to be 5 centimeters. So when I draw my scale drawing, and I am not going to go to the paper and pen again for this one, when I draw this, these lengths should be 5 centimeters and 10 centimeters. I'll label them. That 10 centimeters represents an actual distance of 50 meters, and the 5 centimeters represents an actual distance of 25 meters. And now it is homework. Unit 1, Lesson 9, practice problems. It's not hard, but this did not print off nicely. It's all gray, so I want you to see what it looks like, make note of it, maybe find the section that should be yellow and kind of mark it yellow, find the section that should be blue, mark it blue, find the section that should be red. Because you need to create a scale copy or a scale drawing of that Colombian flag, and it describes the measurements, but if you can't visualize it, then it becomes difficult. Okay, only 4 of those problems today. You've now seen number 2. It is time to get cleaned up. We're going to end the recording, so thanks for watching, and we'll see you next time.